This is Leesha, and I'm recording the CrowdCheer Sprint 2 video. So this sprint I wanted to focus on three stories really. One is that I wanted to lay out the architecture for the entire app, which I had started to work on a little bit last sprint, working on one component of it, but I really wanted to lay it out so I could understand what the rest of the app is going to look like from a technical perspective, and design that out to make sure that the data was flowing in a way that was easy to use, I guess. And then the second story was within that architecture, I wanted to finish up the tracking component of it, which involves once you've identified which runner you've committed to and are going to cheer, you need to track that runner and understand when they're approaching you and when you're supposed to cheer for them, and all of the priming involved in that, so that as a cheerer you have all the information you need to cheer. And then finally, I wanted to test out that tracking component on some users and get some feedback to understand whether we were giving them helpful information and whether it was at the right time. So those are the three main stories. For the architecture layout, I broke it down into these components that you see here. So monitoring has to do with just monitoring any user changes in location, and eventually it could be expanded to monitoring the status of runners in terms of their health. Like, for example, if we wanted to monitor their heart rate or something like that and use that later on to understand when is the best time to intervene with cheers, that could be expanded to support that. And then the identify component has to do with trying to figure out which runners the cheerers should cheer for. So right now, what the identify component is doing is just looking for cheerers, or looking for runners who are nearby you as a cheerer. But later on, we could expand that to support identifying runners who you might have something in common with, like say you both went to the same college and you wanted to have that sort of connection so that the cheer for you was more meaningful. And then the track component, which is the one I worked on this sprint, like I said, has to do with once you've committed to somebody that you're cheering for, you need to be able to track them and have like very accurate contextual information about when they're approaching and when you should cheer, and also just information about them, because in many cases they're going to be a stranger and you don't know anything about them. So things like their name, picture, useful information that allows you to cheer for them. And then the verify component has to do with once the spectator has cheered, we need to make sure that one, they've actually delivered the cheer, so have they cheered out loud? Two, did the runner actually receive the cheer? As in, did they hear it? And then three, ideally we want the runner to have some sort of reaction to it, so that could be translated to like some sort of positive change in performance, or maybe even in post-surveys we could evaluate whether the runner just had a positive feeling about that cheer. But the verify component has to do with essentially verifying the task of cheering and whether it happened. And then the update component has to do with we sort of want to understand who's been cheered and who hasn't, and then distribute cheers based on that. So it's kind of like marking runners as cheered, so that they don't receive more cheers than runners who haven't been cheered at all. And then also in terms of the cheerer, there are situations where the cheerer might not be that they might not be cheering anymore because the race is over, so we need to update their status as well. So it's sort of informing the rest of the cycle, and then we would loop back to this state. So monitoring would start off with the information from update. So that's the basic architecture. And then for the tracking component that it did, basically we wanted to be able to, once the runner was selected, display the information about the runner and then track the runner as they approached on the map. So that had to do a lot with some visual things, and I also had to go in and update the simulation scripts that we had for simulated runs, because testing outdoors is very difficult in the winter, especially. So we set up some Python scripts to simulate data into our parse backend. So let me pull those up. Yeah, so I just went in and modified these so that they are reporting data to another location, because we in parse have two classes now. Originally, in the old version of the app, we were just reporting all the location data points and storing them in one big table, and then looking at that table for the most recent location update for a specific runner, which was really inefficient. So what we're doing now is we're storing it into two separate tables. We have one table where it's just recording all the locations like we were before, but we also have another table where for any new runner, we're looking at their most recent location and updating that location. So it's just a single location point per runner. So we can just look up the runner and what their latest location was. That's a lot faster. So we modified the script to support that. And then once I had the testing script, I could then build out the interface and really like test out whether the map was updating. So I implemented out the tracking protocol, which the tracking component, which uses the prime protocol. And this just has to do with displaying the different information in terms of map updates and understanding where the runner is, and then who the runner is. So this is pretty straightforward. We have different functions in here, like retrieving the runner, getting the runner's location, and then the view controller that matches that basically updates the map. We're tracking the runner here, and then retrieving the runner profile, drawing the map, updating the pin, and things like that. So that's pretty much it. And then the end result was it's basically the same UI that we had last time, but I really wanted to connect it back to the previous architecture so that the data was updating in a way that didn't cause the app to freeze, which is what was happening before. So this is what it looks like right now. The runner icon is actually overlaying the current location icon. You could kind of see it there, but basically from the UI standpoint, you have a map, and then you see the runner approaching you as you're standing at your location. And then you get a picture of them, their name and bib number to help identify them, and then cheer for them, and then a distance value. So once that UI was set up, we started some testing and got that set up, and then continued testing into Sprint 3, which I'll talk about in the next video. Yeah, that's all. Thank you.